Okay, definition, chemistry, what do you guys have for that? There should be two parts to it. I heard something about matter, it sounded good.
Study of matter.
Study of matter, what about the matter?
Study of the properties of matter.
Properties. What's the other part of that?
Action, cultivate, functions.
And actions. Thanks. How about weight and mass? How do those two things differ from each other?
Mass is the amount of that.
Okay, so one, this is amount of stuff. What else we got? Yeah, it's right there. We got that part.
Weights the effect of gravity on that matter.
The so you don't have weight without gravity, but the object is going to have mass no matter what. And so that leads us to weight is based off of what that matter doesn't care about. Okay, but how do you get gravity? Location. So if I'm next to something that has gravity, or next to something that has more gravity or less gravity, then I'm going to have weight. Otherwise, I won't. So weight is this. The weight is position or location dependent. And matter. What about matter? It's not. It's completely independent. Whatever amount of stuff is there, doesn't matter where you are, that mass is still the same amount of mass. How about this next one? What do I got to circle?
One and scientific solution.
They're all the same number.
It didn't fill that way like
They're all, you're looking at the calculator incorrectly.
that. Okay.
They're definitely all the same number. Maybe not
No,
not the same number of decimal places, but they're still the same number. Actually, I think it is the same number of decimal places. Why? Why are there 4 ways to show it? How many different ways can you say to get somebody to stop moving? A lot, right? So the English language is terribly difficult to learn. One of the reasons is because we just have so many damn words for the same thing. Like, what? Just one word would be fine. That's it. German is definitely different. There are multiple words for the same thing, but it's not as pervasive as with us. Math, it's the same situation. So depending on what the situation is, you could see these numbers written in any of these formats. So remember when I said that, actually, you only heard that if you watched the syllabus video, about when you're going to use that math that you learned in like middle school through high school. It's now. Solve the density equation, rearrange it for volume. What does it look like? Volume is equal to mass divided by density. That's about as hard as the algebra gets in this class. Seriously, it's not really getting any harder. The problem is every single one of our problems that we're going to do is a word problem. There's never going to be a time where I'm just going to give you some numbers and ask you to solve stuff. You have to know what those numbers mean and plug them into whatever tool that it is you're going to use to answer it. Unit. What do we got here? Yep. Consistent?
Standard.
I like the word standard measurement. So The two important aspects of this is one, I'm measuring something, and two, that it's standardized. Why is that important?
So we're all on the same page.
We're all on the same page. That's it. I mean, if you go to buy something for $1 and you give somebody $1, you expect that dollar to be enough. But if it's a Canadian dollar, is it the same thing? No, it doesn't have the same value. But it's also not the same thing. It's a Canadian dollar. It's a different thing. So we all have to agree that what I'm using to do the measurement, we all understand what that means, and the thing is measuring something. If I've got something like, say, I don't know, let's go 5 meters. Which one of these two things is more important in this measurement? Say I measure something as 5 meters. The meters is way, 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 way more important. If I just said I measured something and it was 5, is that useful? Really not useful. If I said, hey, I won the lottery and I'm giving everybody 5, like anticipation, what is the unit associated with that 5? Because it could change my life, or I could, buy a Happy Meal. One of the two. So the unit is way, way more important than the actual value, the number. Pure substances. What do we got for pure substances? Okay, that's general. Give me an example. Gold. Great. All right. So gold. What else we got? Sure. Iron. Any molecules? Sure. That's fine. For now. It won't be later. What is salt? When I say salt and you guys think about salt, what am I talking about? Sodium chloride. Okay. We're going to find out that that's one salt. It's like you asking somebody what they want to drink and they say liquid. Okay? I mean, the word salt means so many things to in this class that you can't just say salt. Heterogeneous. Okay. How about cola? How about a Coke? Something like that. Something else? That's heterogeneous? Okay. Any kind of cereal? Raisin Bran, great. You can't say salad dressing, because if it's French dressing, then that's not a heterogeneous mixture. Italian dressing, totally. So we could put French dressing down here. French dressing is definitely a mixture, but it's a homogeneous mixture because it's that Cheeto color orange all the way through. What else for homogeneous?
Can't you use salt now?
No, I can't use salt because salt's a pure substance. Tea? Sure. I like Gatorade. Yeah, we can use like breakfast tea, like black tea, or black coffee, or Gatorade. For sure, absolutely. Any kind of scent. All right, so if a substance has changed color, what type of changes occurred, chemical or physical? And then give an example of a chemical change with a color. Okay, so color changing, so I've got, say, iron, and that turns into rust. And so there's definitely a chemical change, or there's definitely a color change there. And in this case, this color change definitely means chemical change. Because what I start off with is iron, and after the rusting occurs, I end up with Fe2O3. So a totally different molecule. They definitely need oxygen with that, but the thing that I'm looking at was iron colored, and then after it rusts, it's rust colored. The color has changed, and the properties have changed. So this is definitely a chemical change because I have a new substance that's been formed.
Mold.
Mold is so many chemical reactions. It's yeah. I mean, when you say mold, I'm not really sure what you mean. Like
Like
growing of mold,
food.
like moldy food, yeah, there's definitely a chemical reaction happening there. But like thousands upon thousands of them. You said Gatorade, but I don't know what you mean by that. Gatorade what?
Like, you know how they make it colors and stuff?
No, that's going to be physical because the thing that they put into it is that color. So if I take I don't know, water and mix it with say red Kool-Aid, put those two things in a container together, did I get a color change? No, I just mixed two things together that were those colors, and I still have that color. That's it. I'll look at the rest of them when you guys, after you turn those in. All right, so